Hello there, and welcome to part two, where we're looking at how Holdingbay looks at OEE, overall equipment effectiveness, where we manage it for our agency. This one, as we follow on from the first screen, we looked at planning targets for these numbers. The next one is doing data entry. And this is our explainer sheet to walk through the different parts of the data. What we do is we have a one-page sheet which we fill in each week, and then we start rolling that up to look on our trends and on average where the performance is going, and if the programs to change those quality metrics are working or not working enough. So what we've got here is the total shift for each day. Linking back to that page from before, the planned non-productive time, and then we have these columns of non-planned downtime, which sums up our other columns of changeover process. This is when you're switching tasks, missing parts or missing details of a brief, the system going down, or having to wait for other people or other resources when you're working on the project. So these all sum up into the non-planned downtime, which gets added up with the planned non-productive time. Then we've got the total points for that day and the total reworked for that day. So if you like, this is an ideal day. We've had an hour, so that's a lunch break and a couple of short breaks. We've had no downtime, no troubles that week, and we produced our 4 points every day. So we met our mark of 20 points for the day. And by all means, you can up and down this. So you could be that for specific reasons there was a target of 6 points one day, but 2 points the other day, or 6 points every day. I mean, however you want to work it out. We try and work it out as there's a total target we're working for the week. And then we break it down by the days based on our target for our agile workflow for what things need to be done, each person. And some of this may include what is technically rework work, but as I said before, reworked points or fixes, changes, stuff that's been delivered that now needs to be adjusted, counts as a point, but it also counts as a rework point. And then when we score it at the end, there's a cycle time of 100 minutes per total point to give us a theoretical maximum of how many points we can deliver in the day. So the theoretical maximum when we've got total shift time of 540 minutes minus our 60 minutes productive time and non-productive time will give us 480 minutes. So technically we could almost get to 5 points a day. So that's what we sort of give people as a target internally, and for myself is we're trying to shoot for 5, but the target is 4, knowing that if we can get some other stuff done, then that would be good. But realistically, over the week, we just want the consistency. So if you were producing 3 points every day, 5 points every day, whatever that was, it needs to be consistent, because that's what helps us deliver that value and know where we're at and what we're targeting, and we know then the process of setting that stuff up and setting up the time is working properly. This perfect set of days would then give us an availability of 100%, efficiency of 83%, because we didn't get to that 4.8 tasks, 4.7 tasks done in the day, because we don't count points of a task. It needs to be a delivered point. And then quality, there was no rework, so that's 100%, which would give us 83% OEE for every day. So that's a very respectable number, and then obviously that averages out to 83 for the week. Here's maybe a little bit more of a natural week, that there's stuff going on and there's changeovers and things for us. So you've got the 60 minutes non-productive time. So just to go over this again, the availability is worked out as the total shift time minus the not planned non-productive time. So that's the first figure, but then we divide non-productive time by that. So the sum of all the non-productive time, so that's all three of those added together, divided by just the 2, is going to give us our theoretical percentage, or the theoretical target, and therefore, in this case, the percentage of time that you used well, because obviously you're going to have lost that 20 from the total, which will end up, in this case, it's 95% availability, because you weren't available all the day. There were some issues. Now, we don't have, in this case, we haven't recorded which type of downtime that was. So that's more useful, more natural. We would record these and then have this one sum it up. But that's in essence how these are totaled. The efficiency is again a little bit similar. It is the total points multiplied by the cycle time, i.e. the productive time in the day, divided by all the maximum time available minus all the other things that could have changed that availability. So the total time that was actually hands-on working divides the time, the produced results, so that we can see if there was 400 minutes of produced time, for example, productive time was 400 minutes. We know that we, in theory, can't get to that 100% productive, but of that time, how much of the time we had available in the day was used. So we know that it's slightly less than that, and that was 86% in this case. Now, the actual numbers, and that they've got decimals and things, on their own, they're not that important, but what we see them is as trends and just knowing how much better or worse. So it's a relative number. So based on, if our target, for example, here is 95%, and this is why the colours are on here, it's the colours versus the target of how well we're doing with these numbers. So what we want to be able to achieve, and whether these are doing well or not. And obviously they've got slightly different targets for each one. Finally, we've got the quality, which is much simpler. We've just got the total points worked minus half, because they're only worth 50 minutes each, so half the value of the rework time. So in other words, 2 of these points are only worth 50%, divided by the number of points. So that's why we get that. We then end up with 75% was productive for quality control. So we end up with 3 points out of 4. And then the overall quality is availability times efficiency times quality. So you can see that just here doing 2 points of rework, even though the rest of the day was good, has brought down our quality score below the target of 72. And again, with this one, we only delivered 3 points that day, and 1 of those was a rework. The points are down. So you can see this might be a more natural week, where we'd be targeting lifting all that and working out what can we do to make these more efficient. For example, one of the ways we try and do it is line up. If you've got to do rework change requests, try and do 2 or 3 in quick succession, because sometimes they do take time to work out and factor in, but sometimes they are much quicker. They may take half as long as the original work, or they may be even quicker, and you can get through quite a few of those, which can boost your numbers up. Even though you're only getting half the value for them, if you can get through a lot more, they're more valuable than, say, doing 1 request, 1 fix a day. That can affect your numbers a bit more, takes you away from the more valuable work. So we try and switch that around, and also line it up that maybe 1 or 2 people are doing that, rather than sort of being sprinkled around as much to everyone and getting people away from their flow. Because usually change request stuff is going to be outside the flow of what you want to do. It's going to be work that you've already delivered, and then it's come back, so you're not still working on that piece of work. So that's cool. So that just gives us an idea of some days. So even though all of these numbers on their own are fairly positive, the efficiency was a bit down on that week, but it wasn't so as far off. But when these are multiplied together, it's coming in at very little bit under our target of what we want to do. And that's what we see over time. So thank you for joining us.